Hello and welcome to lesson 2 on the topic magnetism and electromagnetism. In this part of the topic, we're not going to be focusing solely on magnetism, but the link with electricity and really getting into electromagnetism. We're going to try and explain what an electromagnet is and how it works. So we're going to be working on these 3 pages in the booklet. You can see that there's a few more past paper questions, a little bit more for you to practice and a little bit less theory to go through. So as I said, we're going to be linking at that link between electricity and magnetism, and that's where we get that electromagnetism title from. So we'll start off with our first page, which is this one, and we're going to have a look at some of the theory. I recommend that you check out our other video on electromagnetism to see the practicals actually in action. So what happens around a wire? Well, when a current flows through a conducting wire, a magnetic field is created around that wire, and you can see that, as I said, in our other video. Now, when you're drawing this magnetic field, it's like a circle around that wire. But as well as that, you also want to be able to draw on the direction of the magnetic field. And so to do this, you need to use the thumbs up rule. Your thumb represents the current, so it points where the current is going. And traditional current always flows from positive to negative. So for example, in this example here, it's flowing from the positive at the bottom to the negative at the top, so you keep your thumbs up. And when you look at your fingers, which are going this way, they represent the direction of the magnetic field. So your fingers are representing the direction of the magnetic field. So in this example, you can see that my fingers are curling around, and so therefore you can see that that's how it looks on the diagram. This is called the right hand rule. Really important that you use your right hand, not your left hand, because that won't work. Now, the strength of the magnetic field depends on 2 things. It depends on the current through the wire. Obviously, the larger the current, the stronger the magnetic field. And again, it also depends on the distance in the wire. The closer you are to the wire, the stronger that magnetic field will be. So if we want to make an improved electromagnet, what could we do? Well, the first thing you do is make what's called a solenoid. A solenoid is where you shape the wire from being a long, thin strand and you twist it round to create the shape below. Shaping the wire to form a solenoid increases the strength of the magnetic field that's created by the current through the wire. The magnetic field inside a solenoid is strong and uniform, meaning it's the same throughout. You need to be able to draw a diagram of the magnetic field, and it looks like so. It's a little bit hard to convert onto your diagram, but you've got those magnetic field lines running through the solenoid and around. You'll see that the shape is very similar to that of a bar magnet. Now, if you want to increase the strength of the magnetic field with your solenoid, what you then want to do is you want to add an iron core into it. An iron core increases the strength of that magnetic field, and we call that assembled product, the solenoid with the iron core, an electromagnet. So it's over to you a little bit more now. We've got a past paper question. There's one quick 1 marker at the top and then a 6 marker. So I want you to pause the video, have a go, and then we'll come back and have a look at the answer, especially for that 6 marker. Okay, so hopefully you're paused and you haven't just carried on the video to find out the answers. So that first question asking us why would we want to use an electromagnet rather than a permanent magnet when sorting rubbish out? Well, the key thing is, going back from the previous lesson, electromagnets can be turned on and off, which allows you to pick up the materials using the force of magnetism, move them to another location, and then turn the electromagnetic off, which would then drop them and releasing them. Okay, let's focus on the 6 mark question. Now, with 6 mark questions, it's really important that you start to understand what the question is asking you. So if we break this question down a little bit, there's usually 2 or 3 parts. In this question, there are 3 main parts. Number 1, you need to describe how you could build an electromagnet. Then you want to talk about how you could vary the electromagnet's design. And thirdly, how you could then test to find out which of those is stronger. To get the full 6 marks, you need to cover all of those areas. We basically can think about it like 2 marks per section, building up to our 6 marks. So building electromagnet, what sort of things might you want to say? Well, you're wrapping the wire around the nail, forming that electromagnet. You want to connect the wire to the power supply. It's amazing how many people forget that stage. And then you want to switch on the power supply. How could we vary it? There's a range of different things that you could do, but 2 of the more obvious ones is that you could change the number of turns on the coil by wrapping the wire more or less around, or you could change the current that's running through the coil. To test it, again, there are a range of different ways that you could do this, but one of the most obvious ones is that you could suspend the paper clips from the electromagnet with the idea that the more paper clips that you can suspend, the stronger the electromagnet is. Okay, over to you on our teacher assess task. This assesses some of the things that we've learned in the previous first and second lesson. So give it a go and see how well you can do. Good luck.